Hi class, welcome to today's lecture. Today's lecture is going to be a very important lecture in terms of insights that Android developers should have. Yeah, okay, so today we are going to study about few things. I'm going to list it down. We'll study about single threaded system, multi-threaded system, synchronization problem, then we'll study about monitor, then executor service, then we'll see locks, okay, then atomicity, and we'll understand about various problems that may arise with this. Okay, so are you all excited? Because this is going to be a very interesting topic. Okay, so important thing to mention today is that Android framework is multi-threaded by itself. Okay, Android is multi-threaded. So if Android is multi-threaded and you don't understand multi-threading, so you don't understand Android. Okay, so you must try to understand multi-threaded. So I have provided you the resources that helps you understand multi-threading, executor service, handler and looper, callable and future. Okay, these resources are available on Mindoc channel of YouTube also, and I have provided you the link in the resources also. You must go through all of them because that will really help you become a better Android developer. Okay, so this is a must to go. Those of you who have not gone through, they must go through them. Okay, this is a 100% recommendation from my side. Okay, now since Android is a multi-threaded system, we need to understand it. So when any Android application starts, it starts with a single thread. Okay, so you have got your process. Process is actually any app. Any app is a process for your OS. When your app starts, a main thread starts. Okay, this main thread is responsible for executing the initial code of your Android and rendering the UI. So that's why this is also called the UI thread. Okay. Now suppose you create a system where you have just one thread. Okay. So what will be the challenges with that? So your application has a single thread. Okay. Thread 1. Suppose you want to execute task 1. This thread will execute the task 1. If you want to execute task 2, this will not be executed till task 1 has been executed. So you will be able to do multiple tasks, but each task has to wait for the previous task to finish. Okay, suppose it was waiting from some input from the user, then you cannot use this thread to make a network call, for example. So this is a waste of your CPU cycles, that is the processing power that you have. This is a waste of that. So this system is not useful. So how we can improve upon it? Okay, so how we can improve upon it is an interesting thing, that using a single thread only, we want to create a system where we can utilize this thread to do this multiple tasks and also to avoid waiting for some IO operation on network calls. Okay, so for that, what we can do, we can create a system like this. Okay, we can create a queue. Okay, we'll call this as event queue, events queue. Okay, this events queue hold events. Okay, what is an event? Anything that you want to do will be wrapped inside an object which is an event. This queue will hold that instance of the events. So we'll have event which will be included in this, and there will be one thread which will be looping through this event. Okay, when it goes to the event, it has include. Okay, so it will take out that event and provide, there will be an event handler. Okay, so this thread will take out an event and supply it to corresponding event handler. So this task consists of two parts now, event and event handler. This event handler will use this thread, this will use this thread to run the code inside the event. Okay, and after, suppose for example, when there is an IO operation, this will use this thread to process the next event till it's waiting. So it will wait till any IO operation or network call, another event can be processed by this thread. So this will reduce the wait time that we had. So this will optimize this thing. Okay, so now we have got a single thread, but this is more optimized in usage. Okay, but suppose you have got multiple cores in your CPU, you have got multiple cores. So one thread can only execute in a one core. So again, you will not be able to utilize your resources that you have. So single thread system will not be useful in a multi-core system. So for that, we need to have a better system. So can you think of any better system than this? Yes, so I'll tell you that in order to make the system better, what we can do is we can use multiple threads rather than a single thread. That is the most obvious thing. Okay, so for example, you have got again a process, your app. This process, this app, when starts, will start one thread, main thread. Okay, it can also start other threads, for example thread 1, thread 2. Okay, and using this thread you can execute, for example task 1, task 2, main thread will do its usual things. So if suppose there are 4 cores, all these 3 tasks can run parallelly. So this is the advantage of multi-threading. Okay, but if you create a large number of threads, say 1000, then there will be more time taken in the other things. Okay, for example, suppose you have got 2 cores, okay, and you have got 4 threads. Okay, only 2 threads can run at one time. So suppose 1 and 2 is utilizing the CPU, then they are waiting. Okay, now when T1 is suppose waiting for some IO operation or it finished, then other thread will be given the chance. Okay, so there is thread switching taking place between two threads. Okay, task switching taking place between two threads. So this is an overhead. So more number of threads you have, more will be this operation, and there will be more time required in switching between the threads rather than utilizing them to process your task. Okay, so this is why creating more number of thread is bad for your application. So you must create an optimized number of threads. Okay, now there are two things, two problems that arise with multi-threading. One is you cannot create the number of threads, large number cannot be large. Second is synchronization. Okay, let's first understand synchronization. What do I mean by this problem? Okay, so suppose you have got an application. Okay, this is your app, and this app sells something to the user. Okay, and in your app you have maintained a database to manage the pricing. Okay, so there are various items in your database. Item 1, item 2, item 3. Okay, there are various items. Suppose app made a purchase, user made a purchase based on some pricing that you shown to the user. Okay, now this, after this purchase you are generating a receipt. Okay, so for creating a receipt, this thread needs to call this database. Okay, suppose this is T1 and there is another background service which is responsible for keeping these prices updated. So while you are doing all these things, your background service went to the server and get the new prices and update them. This was thread 2. So while you are creating the receipt using thread 1, you are calling database to get the prices of various items, and at the same time a background service get these prices from server and started writing this new prices. So this receipt will now be generated with the new price. Okay, so you'll get a mismatch between receipt and the purchase, and user is most likely to uninstall your application, even file a lot of things for your application. Okay, so this such system will create an evoke. Okay, so when we have something which you need to guard again multiple read and writes. Okay, for example, when thread 1 is accessing, we don't want thread 2 to do anything, so this is called synchronization, that is coordinating between multiple threads, is called synchronization. So this is very important for a multi-threaded system, that you will have to think how we need to synchronize between the threads. Okay, so what is the medium that is available for us to actually synchronize our code? Okay, so I'm considering Java here because when you understand things with Java, Kotlin comes automatically, and it's better to understand things in Java, as I think. Okay, so Java has concept of monitor. Okay, so what is this monitor? So monitor is associated with an object instance. Okay, object instance, one monitor is with one object instance. Okay, so suppose you have got an object and it has got certain methods. Okay, for example, method 1, method 2, method 3 and method 4, and method 4 is static. Okay, so whatever you have written in method 1, this will be guarded by a monitor if you write a keyword synchronized in front of it. If you write synchronized keyword in front of a method, it gets a monitor by the Java language. Okay, so essentially what monitor is, so monitor, you can think it like this. You have a monitor. When some thread is inside this monitor, any other thread who is trying to get into this monitor will be suspended. So T2 and T3 will be waiting while T1 is inside this monitor. T1 can re-enter this monitor any number of times, that is T1 can call this method n number of times. When T1 leaves, any of these two will be provided the next chance to get into the monitor. So this is how monitor achieves synchronization. So when you put synchronized keyword in place of a method, it gets a monitor, and this monitor is the instance of the object. Okay, and you will further learn that this monitor is same as synchronizing with this object lock. Okay, so suppose method 1 is synchronized, method 2 is synchronized, okay, and static is synchronized. So suppose you have got thread 1 calls method 1, thread 2 calls method 2, thread 3 calls method 3 and thread 4 calls method 4. Okay. Now if I will ask you that if thread 1 calls the synchronize method, okay, and then after some time thread 2 calls the synchronize method and T1 was inside this method, will T1 be able to execute? And similarly at the same time T3 also calls, T4 also calls. So when T1 first enters into the instance, okay, so any thread which is trying to access the instance variables will wait if it is also synchronized. So T1, when it is calling method 1 of this object which is synchronized, T2 also calls method 2 of the synchronized. After T1 has called this method, it will wait till T1 comes out of this synchronized method, comes out of this monitor. Both of them get the same monitor because it is on the same object. And T3 will be able to, it will not wait. Why? Because it is not synchronized, it does not have any monitor. Okay, any thread can access anytime, and this is static method, so this will not wait. Why? Because this is static, this will be synchronized through the class level lock. Okay, so this is how synchronized block helps in achieving the synchronization between various methods in the object. Okay, so you can use synchronized in front of method, static and instance methods, and also you can use synchronized blocks. Okay, so this was about your monitor, which is by default in Java language, and it helped to enforce synchronization in your code base. But there are certain cases where we need to go beyond this. Okay, so now that we have understood that synchronization was important, and by default Java has provided us a way of enforcing synchronization, but suppose you have this case where you have got two objects, object 1 and object 2. Okay, so object 1 has one method which is synchronized, and this is synchronized. Okay, writing shorthand here. If some thread T1 calls this method 1 and T2 calls this method 2, we would want in some case that when T1 is inside this method 1, any thread should also not execute some other method in object 2. So this cannot be achieved by this object, because synchronized keyword can only synchronize the methods of one object, not in other object. So here we need to synchronize object between synchronized methods between objects. Okay, so this can be achieved by using lock. Okay, so lock is another way of synchronization. Okay, so we will now discuss about the locks. It is available in Java Utils concurrent package. Okay, so I think everybody is getting the role of why we are using lock. Okay, okay. So lock is an interface, okay, which provide the mechanism of synchronizing between threads. Okay, so there are two locks. The lock, there is one implementation is reentrant lock. Okay, what reentrant lock? This is same as the default your monitor, but it can work across object. So basically reentrant is same as your monitor. When one thread is inside, it can reenter anytime it wants, but other threads will have to wait till T1 get out. Call this, there is .lock method on the instance. When you create a lock, you will create an instance of reentrant lock and you will call the lock method. Then the thread 1 will get lock. Any other thread which tries to call the lock will be in the waiting state, suspended till T1 calls this lock dot unlock. Okay, this unlock method, when it calls, any other thread will get the chance to execute. Okay, so this is your reintrant lock. There is one more important one, is read write lock. So read write lock is again an interface, and one implementation is reintrant read write lock. Okay, so one of the use case I will tell you is that suppose you have got your database. Okay, now database allows any thread to read without any blocking. That is, T1 and T2 can read the data from this any table in the database simultaneously. Okay, but if some other thread, for example T3, is going to, suppose this is reading, this is also reading, and this is writing. So when T3 comes and starts to write the DB, any thread either which wants to read or any other thread which wants to write, for example, also it wants to write, they will all wait till one thread is writing. So writing will block all other threads till it has written, but reading can be done without blocking. So this is one use case of a reintrant read write lock. Okay. Now we saw how synchronization is important and how we can achieve synchronization using lock and monitor. Okay, now suppose coming back to the original problem, the problem was that we want to reuse the threads. Okay, so suppose we want to create number of core is n and we create n+1 threads. So we want that this thread should be kept alive and utilized to do task. Okay, to do that we have got executor service. Okay. Okay, so executor service allows you to create a fixed number of threads and utilize them to execute task. Okay, so in order to create the instance, this is actually an interface. Okay, in order to create the instance of this, you have got the one of the implementation of this is thread pool executor. Okay, so when you try to create one instance of executor service, there are static methods in executors. Okay, executors is a class, so there are three one. First is new cached, okay, pool, thread pool. Second one is your new fixed thread pool. Okay, and third one is your new scheduled thread pool. Okay, the difference between them is that cached thread pool will initially create one thread, and as you need it will keep adding number of threads later. Fixed thread pool will start with the number of threads you provide. For example, 5 threads, you will tell it create 5 threads, keep it and use them to process the messages. Okay, the task you provide. Okay, scheduled is for running scheduled tasks, which we are not discussing right now. Now executor service has got two modes. Executor service has got two modes, one that returns a result and one that do not. Okay, so we have two modes of task scheduling. If suppose we want to get the result, that suppose we gave a task to a thread and it executed that task, and then it can send back a result to the caller, or we do not want the result. So there are two modes in which you can run. Okay, so here when you call executor service instance dot execute, this is a method there, execute, and here you need to supply your runnable. When you call this, it will run whatever is there in the runnable code run method, and simply it will finish. Okay, it will go, the thread will now be available for doing other operation. But if you want to get the result, there is a method executor service dot submit. Okay, when you call executor service dot submit, it returns something. Okay, so here it takes callable. Okay, callable is similar to runnable. Okay, you define the callable same as runnable, it is an interface. Okay, but here you must return in this callable when you implement. So when you implement the method inside, you must return a result or throw an error. So it takes callable, and then when you implement a callable in the method, you must return the result or throw an error. Okay, when you call a submit, it returns a future of this type of result. Okay, so when you call submit, you pass the callable. Callable is same as runnable, but when you implement, you need to return a result or throw an error. When you call submit, it returns a future. Okay, future basically you will refer to the result in a variable which is of type future and type the return that you return. Okay, now the role of this is that this is a promise that in future I will be supplying some result. Okay, so when you want to get the result, you will call result.get. Okay, so suppose you store this into the result. When you call result.get, then this thread, suppose this submit was called by a thread T1. Okay, and when T1 calls executor service.submit, this block of code will be executed from one of the thread in the executor service in some other thread T2. When T1 thread calls result, that is returned from the submit.get, it will wait. It will be waiting till T2 returns the result. Okay, so it will get a result here. Okay, so the role of a future is to get the result, and when you call result.get, this thread will wait. If the result is being processing, it will wait for that result. If it has already been processed before you call get, it will directly get the result. Okay, so now you can get the result from some thread to another thread. Okay, so this is one of the very good advantage of using executor service. Okay, RxJava internally uses executor itself. Okay, so if you don't understand, that's fine, you can use RxJava, but sometime in your career there will be a case that will arise. For example, it arises with me where I had to ship an application whose size has to be minimum. Okay, we cannot afford to use any external libraries, so we need to use anything provided in the Java. Okay, so it will be helpful in your career sometime. Okay, and it will also help you understand RxJava. If you want to later modify RxJava, create your own operators, then you must know all these things, because magic is not inside RxJava, magic is inside all these things. Okay, there is one concept called atomicity. So atomicity, it was earlier asked when I use atomic boolean, for example. It was asked and I told that I will reply. So what is the role of atomic boolean? Okay, so atomicity or atomic operations are an operation that happens in a single processing cycle. Okay, so for example, you have got a normal boolean I is equals to true. Okay, so suppose one thread calls this, it is inside, for example, a method. Okay, one thread enters this method and it creates a boolean I and sets a value. Okay, so there, and suppose if I write if I is equals to false, then set I is equals to, just writing it like this, true. Suppose I write this, I was a boolean, and if I compare if I was false, okay, then set I as true. So there are two instructions. So one instruction is that I am comparing and another is I am setting the value. Okay, so suppose this was a critical for synchronization. Okay, we want that this block of code should only be executed by a single thread. Suppose T1 was checking that I was false, so till then some other thread can also set it to true. Okay, so thread 1 enters into this block checking that I was false, but some other thread which went into this loop before this T1 set it to true. So now there is a mismatch. Now this inside this loop T1 gets with the condition that I was false but I was set to true while it was checking. So these two operations provide us a loophole for two threads to create discrepancies. Okay, so suppose in those cases we want that these two instructions should be executed in a one CPU processing cycle. Okay, that is, this checking and setting should happen once. So for that we have atomic booleans. Okay, so when you call get and set, it will be a single operation. So any thread which called get and set, another thread cannot set it while T1 is getting it. Okay, so this is the role of atomic boolean. Okay, so for synchronizing object we saw the lock. Okay, there is one more construct which is very important, which serve very important. Okay, and that is countdown latch. So countdown latch act as a lock itself, but it provides a different way. For example, you have got an object, okay, any resource, okay, a method, for example, okay, this is T1, T2, T3, T4. So when you create a countdown latch, you define the countdown. For example, countdown 1. Okay, so when one thread enters this method, for example, it calls latch. This is the instance of countdown latch, and it calls latch.await. When it calls any thread for the first time, calls latch.await, any other thread which get into this code block and calls latch.await will be suspended. This will be suspended till this will be suspended till T1 calls latch.countdown. Okay, till the latch.countdown is called by the first thread who is called latch.await, all other threads will wait who also tries to call latch.await. Okay, so it is acting like we want to restrict all other threads till T1 has been completed. Okay, and after T1 calls countdown the latch, all of them can access this resource. Okay, so in certain conditions we want to, for example, restrict all other operations till one important operation is complete. Okay, in that case countdown latch is important. Okay, for example, we are synchronizing from the server. Okay, so when this server is writing something on the file, for example, or database, anything which is trying to access it will be wait while this writes it. Okay, or there can be another use case also. So main thing is that we want to stop all other threads till one important operation performed by some other thread has been done. Okay, so this is the role of countdown latch. Okay. Yeah, okay. So there is the last concept which I am going to discuss is a deadlock. Deadlock appears in your production code more often, okay, and it is very difficult to actually debug. So basically, let's give a simple example. Okay, this is thread 1 T1. Okay, this is thread T2. This is object 1. This is object 2. This is in method, some method 1, for example. This is inside this method 2. Okay, and these two methods are synchronized, and this is also synchronized. Okay, now T1 is calling the method 1 of object 1, and this is synchronized, so it gets into the monitor. Okay, at the same time T2 thread gets into object 2, and this is also in a synchronized method, so it has got in one monitor, it is in one monitor. Now T1 depends on T2, so at the same time T1 calls the method 2 of the object 2 which was synchronized, so it will only execute this code till T1 exits, and T1 calls the method 1 of object 1. Now what do you think? Can T1 and T2 run in this case? So if you see that T1 will wait for T2 to be removed from this monitor, and T2 will wait for T1. So this is your deadlock. Okay. So deadlock appears due to, for example, synchronization that you are trying to enforce, and two or more threads start to wait to access that lock, and none of them can either release the lock and get the lock. Okay, in your code synchronization, this deadlock will not appear in this simple manner, it will be more convoluted. For example, thread 1 can call thread 2, can call, and suppose object 1, it can call object 2, and this will call object 3, and there will be another thread T3. Okay, so it will be in a very rigid chain, that one thing will call another, and finally two or more things will be waiting for some common resource. Okay, so deadlock is very difficult to actually debug, and this comes in your production very frequently. For example, shared preferences, I had got a lot of these errors. So whenever you get this error, you need to examine that from where the origin of this. For example, you are getting a deadlock on some place. For example, you have written some broadcast receiver, and you are getting deadlock there. Okay, so in that case you need to go and see that why this deadlock can happen. For example, you have include a job in the job service. Okay, so that job must be creating one other thread, and there will be another loop. So you have to first go from the origin and go through all the implementation and see how locks has been designed, okay, in your code, and then figure out that why the locking can happen. So this will be a difficult thing to debug, and this will come in your production also, okay. So you have to take care of this when you are designing your multi-threaded programs, okay. So I'll end here.